At 21:40 Universal Time last night, a machine in Buenos Aires printed a shape. Not a photograph, a shape. 5 pairs of coordinates that, joined together, draw a lopsided smear of nothing in particular, drifting east across southern Peru at 15 knots. And underneath that shape sat a single number, printed without comment, the way you'd print a room number on a door. 240. If you have ever taken a long flight, you have lived inside that number. Flight level 240 means 24,000 feet above sea level. Think of the sky as a building with numbered floors. The weather you can see out your window lives on the lower floors. Cruising jets live upstairs. 24,000 feet is the landing where the climb ends and the long, smooth part of your flight begins, the point where the seatbelt sign goes off and somebody starts pushing a cart down the aisle. That number was on the bulletin because something had reached that floor. Not a storm, not a jet, ash. Ground up rock, sharp as broken glass and finer than talcum powder, thrown up out of a mountain in the Peruvian Andes called Sabancaya and shoved east by the wind. And here is the part that made me sit up. That bulletin from Buenos Aires was not the only one issued in that window. In Darwin, Australia, forecasters were writing an advisory about Semeru on the island of Java. In Tokyo, analysts were watching Kanlaon on Negros Island in the central Philippines. In Washington and in Popayan, Colombia, scientists were logging ash emissions from a mountain called Puracé, which has been behaving in a way nobody there has ever recorded before. 4 volcanoes, 4 countries, 4 different agencies, working in 3 languages, none of them mentioning the others because none of them had any reason to, and within hours, the internet had turned that into one sentence. The planet is waking up. So let me do what I came here to do. I am going to walk you through all 4 of these using only what the monitoring agencies actually published. I am going to tell you plainly whether they are connected, and the honest answer is going to disappoint some of you. And then I'm going to show you the one number in this entire story that genuinely worries the people whose job it is to worry, because it is not the number you think it is, and it is not on the volcano you think it is. If that is the kind of breakdown you want on nights like this, the numbers instead of the noise, subscribing takes 2 seconds, and it is the entire reason this channel exists. Let me start with what actually landed on those desks. Semeru first. It sits on the eastern end of Java in Indonesia, and at 3,657 meters, it is the tallest mountain on the island. It has not stopped erupting in years. That is not a dramatic statement. It is a bookkeeping one. Indonesia's volcanology agency, whose name shortens to PVMBG, has been publishing daily notes on Semeru all month, and they read like a factory log. During the first half of August, gray and white-gray ash plumes rose between 300 and 1,100 meters above the summit, drifting in whatever direction the wind happened to be going that morning. On the 12th of the month, the seismic network counted 100 separate explosions in a single day, 100. And the alert level did not move, because for Semeru, that is Tuesday. The alert has been sitting at level 3, called standby, on a scale that goes to 4. Late on the 18th, the Darwin Ash Advisory Center put out a bulletin describing an ash cloud reaching an estimated 15,000 feet, moving northeast at 5 knots. 15,000 feet. Well below the floor where the jets live, but high enough to matter to anyone flying lower or landing nearby. Now, Kanlaon, in the Philippines, 2,435 meters tall, sitting on Negros Island in the middle of the country, in the middle of the region that grows most of the nation's sugar. It has been at alert level 2 on a 0 to 5 scale since late July of last year. Not for days, for more than a year. During the first half of this month, the Philippine Institute known as PHI-Volcs was logging between 1 and 5 volcanic earthquakes a day, and sulfur dioxide output swinging between roughly 650 and roughly 1,500 tons every 24 hours. On the 15th, Cameras caught 2 ash emissions in the space of 25 minutes before dawn, gray plumes rising about 200 meters above the crater and drifting north. The 4-kilometer permanent danger zone around the summit stayed closed, the way it has stayed closed, through 7 separate eruptive events this year. There is one detail about Kanlaon that volcanologists there watch more closely than the ash. Filipino has a word for it, banag, and it describes a reddish glow visible over the summit at night. Infrared and high-resolution cameras at the Kanlaon Observatory have been catching that glow intermittently for well over a year, and the frequency of it increased sharply this spring to the point where it was observed visually rather than only through instruments. A glow means heat is close enough to the surface to be seen from 8 kilometers away in the dark. Fivolks has described the underlying mechanism plainly, and it is a repeating pattern at that mountain. Gas pathways from a deep magma source get blocked, pressure builds behind the blockage, the edifice swells, and eventually the system clears its own throat in a short, sharp explosion. Then it starts over. Sabancaya, in southern Peru, is the tall one. Its summit stands at 5,967 meters, which is 19,577 feet. Read that again, because it changes the math on everything I am about to say. Sabancaya's crater is already almost at the altitude where airliners cruise. Peru's Geophysical Institute has it at orange, level 3 on a 4-color scale, and has had it there for a long stretch. In early August, their monitoring network counted 43 earthquakes tied to magma and gas moving underground in a single week. Sulfur dioxide has been averaging around 880 tons a day. The exclusion radius is 12 kilometers, and it is enforced. To put a human frame on that exclusion zone, Sabancaya stands in the Arequipa region, near the rim of the Colca Canyon, one of the deepest canyons on Earth and one of the most visited landscapes in Peru. Tour buses run past that mountain. Villages sit on its lower slopes, growing crops and soil that exist precisely because volcanoes there have been dropping ash on it for thousands of years. That is the deal people make with a mountain like this one, and they have been making it for generations. The 12-kilometer line is not a suggestion drawn by a bureaucrat. It is the distance the agency has calculated that ballistic rock fragments and surging gas could plausibly reach if the mountain does something abrupt. And the reason it stays quiet in the news is that people mostly respect it. And then Puracé, in the Colombian Andes, above the city of Popayan. And Puracé is where this story stops being routine. But before I show you why, I have to deal with the sentence that will be all over your feed today. Because if I do not deal with it now, everything else I tell you will land wrong. You are going to see this event described as 4 volcanoes on 4 continents. It is not. Indonesia and the Philippines are both in Asia. Peru and Colombia are both in South America. 4 countries, yes. 4 monitoring agencies, yes. 2 continents. The detail got upgraded somewhere between the bulletin and the caption, the way details always do, and once you notice that one, you start noticing the rest. Here is the second thing. And this one matters more. These 4 eruptions are not connected to each other. Not loosely, not subtly, not in some way scientists are too cautious to admit. The Smithsonian's Global Volcanism program keeps the running count for the whole planet, and their own summary of the numbers is blunt. At any given time, there are typically between 40 and 50 volcanoes in continuing eruption worldwide, and of those, roughly 20 are actively erupting on any particular day. 20 today, yesterday, the day you were born. The Smithsonian and the United States Geological Survey publish a joint weekly summary of notable volcanic activity, and the edition covering the week that ended on the 12th of this month carried updates on 26 volcanoes, 26 in 7 days. The long-run average since that report started, a quarter century ago, is about 17 volcanoes a week. So 4 in one night is not a signal. 4 in one night is a slow night that happened to get noticed. And there is a physical reason they cannot be pushing each other around. Semeru and Sabancaya are separated by roughly 17,000 kilometers of planet. Their magma comes from different subduction zones, feeding different crustal systems under different oceans on different plates. A volcano's plumbing is local. It is a column of hot rock and gas working its way up through the specific few kilometers of crust directly beneath it, responding to the pressure in that column and almost nothing else. Two volcanoes on opposite sides of the Pacific have about as much to do with each other as two kettles boiling in two different houses on two different streets. What connects them is not geology, it is us. It is the fact that in the last 30 years, we wrapped this planet in satellites, seismometers, gas sensors, and webcams, and built 9 ash advisory centers that publish in near real time, so that a 200-meter ash puff on an island most people cannot find on a map now generates a document that lands on a screen within minutes. We did not get more volcanoes, we got better microphones. It is worth understanding how one of those bulletins actually comes together, because once you see the machinery, you stop misreading the output. The advisory on Sabancaya listed its information sources on the document itself. A geostationary satellite parked over the Americas, a numerical weather model, a webcam pointed at the mountain, 3 completely different ways of looking at the same column of ash, cross-checked against each other, then converted into coordinates, a floor number, a direction, and a speed. The advisory on Semeru named a Japanese weather satellite and Indonesia's own volcanology agency as its inputs. And the forecasters do not only describe where the ash is, they project where it will be 6 hours from now, 12 hours from now, 18 hours from now, so an airline dispatcher in another hemisphere can replan a route before the aircraft ever leaves the gate. Read one of these documents and you notice how careful they are. When the satellite cannot confirm what the ground observers reported, the bulletin says so in plain language, and sometimes it says the ash is not identifiable in the latest imagery at all. That is a monitoring system admitting the limits of what it can see, in writing, in public, at 3 in the morning. It is the opposite of hype, which is exactly why it is so easy to strip a single number out of 1 and turn it into something it never claimed to be. Which brings me back to Puracé, because Puracé is the one where the microphones are picking up something new. Puracé is a stratovolcano in Colombia's Cauca department, part of a chain of 7 cones and craters called Los Coconucos. It last erupted in 2023. In January of this year, the Colombian Geological Survey, the SGC, actually lowered its alert from orange down to yellow because the monitored parameters were declining. Things were calming down. That is the baseline you need in your head. On the 20th of July, that reversed. The SGC began detecting a new increase in activity, and it did not level off. It kept climbing. Through the last days of July, the seismic network recorded the amplitude of continuous tremor rising, along with the specific signal shapes that mean ash is being pushed out of the vent. Gas and ash emissions climbed as high as 3.4 kilometers above the crater rim. The temperature of material coming out of the ground reached 140 degrees Celsius. Sulfur dioxide output peaked at 4,200 tons in a single day. Carbon dioxide measured in the soil around the volcano reached 688 parts per million. And ground deformation was showing up in the area between the Puracé, Payocalo, and Curiquinga cones, meaning the shape of the mountain itself was changing. Now, hold all of that next to one sentence from the agency, because this is the sentence that matters more than any single figure. The SGC stated that these were the highest values recorded there since instrumental monitoring of the volcano began. Not the highest this year, the highest ever measured at that mountain. On the 1st of August, they raised the alert from yellow back up to orange. Colombia's director of geohazards explained the reasoning without softening it, saying the new level reflects a greater likelihood of a major eruption than the smaller events of recent weeks. And then the volcano kept going. Between the afternoon of the 9th and the afternoon of the 10th, 5 ash emissions, the tallest around 700 meters. Between the 11th and the 12th, 6 more, up to 500 meters. Residents in the rural areas of Cristales and Alto Anambio watched them go up. The airport serving Papillon suspended operations as a precaution. And regional indigenous authorities in Cauca, who represent communities living directly on that mountain's flanks, publicly asked for more attention to the people in the affected territory, which tells you everything about who actually absorbs the risk here. And there is one more thing about Puracé that I need you to hear correctly, because the misinformation on this one is already circulating. On the 10th of August, a magnitude 7.4 earthquake struck western Colombia. Same country, same morning, same news cycle. The connection wrote itself, and people made it instantly. The Colombian Geological Survey addressed it directly, and their answer was no. Puracé's escalation had already begun weeks before the earthquake back on the 20th of July. The monitoring data showed no additional change in the volcano's behavior attributable to the quake. Two significant events, same country, same day, no causal link. If you take one habit away from this video, make it that one. Same day is not the same as because. So 4 ash advisories in one night is normal. And a volcano posting the highest readings in its monitored history is not normal. Both of those things are true at the same time, and only one of them is on the thumbnail of most videos you'll see about this. Now, let me go back to that number I opened with, because I have been holding it deliberately. 24,000 feet, flight level 240, Sabancaya's plume, drifting east. Here is why that specific figure earns its place at the top of this story, while a 15,000-foot plume at Semeru does not. Sabancaya's summit already sits at 19,500 feet. It starts most of the way up the building. It only has to lift its ash a few thousand feet above its own crater to be standing in the corridor where transcontinental traffic moves. A volcano at sea level has to work enormously hard to put ash where the jets are. A volcano that is itself nearly at cruising altitude does not. Have you ever been on a flight that got diverted or grounded and never found out why? Drop it in the comments, because a surprising number of those stories turn out to have a mountain in them, and I read every one. Now, what actually happens when a jet and an ash cloud occupy the same floor? On the 24th of June, 1982, a British Airways Boeing 747 was flying from Kuala Lumpur to Perth with 247 people aboard. At 37,000 feet in the dark, the crew watched a strange glow crawl across the windshield and the leading edges. Then, one after another, all 4 engines shut down. The aircraft's weather radar showed nothing. It could not. Radar looks for water droplets, and volcanic ash is bone dry. They were flying through a cloud thrown up by Mount Galunggung on Java, and nothing in the cockpit could see it. Captain Eric Moody made an announcement that has since become the most understated sentence in aviation history, telling passengers that all 4 engines had stopped and the crew were doing their damnedest to get them going again. The jumbo glided down more than 20,000 feet. As it descended, the engines cooled, and the melted ash that had fused itself onto the turbine blades cracked and broke away. At 13,000 feet, 1 engine caught, then the others. They landed at Jakarta with a windshield sandblasted almost opaque, and the pilot had to look out through a small clear strip at the edge to see the runway. 7 years later, in December of 1989, a KLM 747 carrying 245 people flew into ash from Mount Redoubt in Alaska. All 4 engines failed again. The crew fell more than 4,000 meters before they got them restarted, landed at Anchorage, and the airline was handed a repair bill of more than $80 million for a plane that was less than 6 months old. Nobody died in either incident. Both were closer than anyone likes to say out loud. And those 2 flights are the reason the ash advisory centers exist at all, and the reason a computer in Buenos Aires prints a shape and a floor number in the middle of the night for a mountain in the Andes with nobody standing on it. The mechanism behind those failures is worth understanding, because it explains why the response to ash is so much more aggressive than the response to almost any other airborne hazard. Volcanic ash is not soot, and it is not smoke. It is pulverized rock and volcanic glass, jagged at the microscopic level, and it starts to soften and melt at temperatures well below the operating temperature inside a modern jet engine's combustion section. So the ash enters as dry dust, turns to molten glass in the hot part of the engine, and then coats the turbine blades downstream where things are marginally cooler. That coating narrows the passages the airflow has to squeeze through. The engine stalls and shuts itself down. The cruel elegance of it is what saves the aircraft. Shut down, the engine cools. The glass on the blades contracts, goes brittle, cracks, and flakes off in the airstream, which is why both of those crews got their engines back only after they had fallen thousands of feet, and why both incidents ended with a landing instead of a hole in the ground. Meanwhile, the same particles are stripping the windshield like sandblasting equipment, scouring the paint off the leading edges, and choking the sensors the aircraft uses to know how fast it is going. And none of it shows up on radar. Weather radar is built to find water. Ash is dry. From the cockpit at night, an ash cloud is simply a piece of sky. And if you think that history is safely in the past, look at what happened in Europe over the last 2 weeks. Mount Etna on Sicily has been erupting through August. Ash from it drifted as far as Malta and, at one point, all the way to Libya. Catania's Vincenzo Bellini Airport sits about 30 kilometers south of the mountain, handles at least 40,000 passengers on a normal day, and is Italy's 5th busiest hub. It was shut down repeatedly. Across one 7-day stretch, more than a third of the roughly 2,000 scheduled flights were canceled and around 600 more were diverted. Airport authorities described it as the worst disruption they had seen in more than 2 decades. Thousands of travelers were stranded in the peak week of the European summer, and Italy's civil protection minister ended up in a public argument about whether it makes sense to have a major international airport parked at the foot of the most active volcano in Europe. The airport reopened on the 15th, once the aviation color code was downgraded from red to orange. That is what an ash advisory looks like when it stops being a document and starts being your holiday. And it happened this month on the continent that was left out of the 4-continent headline entirely. Which brings me to the 2 mountains I have not given enough time to, and to the people who live on them. Semeru and Kanlaon are what I think of as threshold volcanoes. They erupt so regularly that their activity has stopped clearing the bar for international news, which is a strange kind of invisibility to be granted. Semeru's alert has been parked at standby, level 3 of 4, month after month. Kanlaon has been at alert level 2 since July of last year, with its 4-kilometer permanent danger zone continuously closed and its edifice slowly swelling since 2022 as magma intrudes at depth. For the people below them, none of this is background noise. Semeru rises above one of the most densely settled agricultural landscapes on the planet. Java holds well over 100 million people on an island roughly the size of the state of New York, and a great many of them live on the flanks of volcanoes for the same reason people have always lived there, because the soil is extraordinary. The hazard on Semeru's slopes is not usually the ash column at all. It is what happens afterward, when heavy rain hits loose volcanic debris on a steep mountainside and turns it into a fast, dense slurry of mud and rock that follows the river valleys downhill. Indonesian authorities repeatedly warn communities along those drainages to stay out of the channels during rainfall, and that warning is not theoretical. That is the hazard that has done the killing there before. Kanlaon sits in the heart of the Philippine sugar belt. When it produced a moderately explosive eruption in February, ashfall and the smell of sulfur reached around 40 villages across Negros Occidental, and health authorities told residents to wear masks. In July, a 3-minute eruption sent ash over parts of Cebu province and grounded domestic flights at one of the country's busiest airports. Farmers there have absorbed enormous agricultural losses across this eruptive sequence. Ash does not have to fall thickly to ruin a harvest. And that is the part of the preparedness conversation that gets skipped. If you live downwind of an active volcano, the practical advice is unglamorous and it is the same everywhere on Earth. Keep a mask that filters fine particles. Have a plan for keeping ash out of your water supply. Know your danger zone by number and stay out of it, even when the mountain has been quiet for weeks, because these systems do not announce themselves politely. And take your instructions from the observatory, not from a video, including this one. So let me close the loop on the question I promised to answer. Is the planet doing something? No, not in the way the headline means it. 4 ash advisories in one night is an ordinary night on a planet where about 20 volcanoes are erupting at any moment, and a joint Smithsonian and Geological Survey bulletin averages 17 updates a week. The 4 countries are real, the 4 continents are not, and the 4 mountains have no more influence on each other than 4 strangers reading 4 different newspapers. But here is what is genuinely worth your attention, and I want to be as precise about this as I was about the debunk. One volcano in this group is recording numbers it has never recorded before. The gas output, the ground temperature, the soil chemistry, the deformation across 3 separate cones. Colombia's own geological survey put those readings at the highest level in the instrumented history of that mountain and raised the alert accordingly. That is not a viral claim. That is a national agency writing down what its instruments told it and then acting on it. And I want to be careful about what orange means, because this is where a lot of people go wrong in both directions. Orange does not mean an eruption is coming. It does not mean a date has been circled. It means the probability of a significant eruption has meaningfully increased relative to where it was, and that the agency wants emergency planning to move forward now rather than later. Volcanoes escalate and then stand down all the time. Puracé itself was walked down from orange to yellow back in January, only to be walked straight back up 7 months later. That is the system working, not the system panicking. There is a real cost to getting this wrong in the loud direction, too. Every time a channel turns an orange alert into an imminent catastrophe and the mountain then does nothing for 6 months, a few thousand people learn to stop listening. And the day one of these agencies raises a level for a reason that genuinely matters, those people scroll past it. Honest calibration is not the boring alternative to alarm. On a long enough timeline, it is the thing that keeps alarm useful. And here is where the next chapter gets written. Puracé's alert stays at orange, and the numbers to watch are the ones the SGC keeps publishing. The tremor amplitude, the sulfur dioxide, the deformation between those 3 cones. Sabancaya keeps putting ash toward the floor where the jets live, and Buenos Aires keeps printing shapes. Semeru and Kanlaon keep doing what they have done for years, and the danger zones around them stay closed. And on the other side of the planet, Hawaii's Volcano Observatory has already published a window. Kilauea's summit eruption is currently paused. Episode 53 ended on the 13th of August. The tilt meters at the summit began re-inflating almost immediately, and preliminary data suggests the next fountaining episode is likely to begin between the 21st and the 27th of this month, which means that within days, there is a decent chance we get a 5th volcano on this list, on a continent nobody has counted yet, and the whole cycle starts over. When it does, I will have the numbers here before the captions catch up. Hit subscribe and turn the bell on so you get that one when it lands, because Kilauea does not wait for anybody's schedule, and neither does the mountain above Popayan.